Hi, my name is dr. Ahmath. From this video lecture, we are going to start our discussions about the estimating the parameter of population. So in today's lecture, we are going to discuss the general picture of the process of this estimation, how to find a one-point estimator, how to find the interval estimator of the population parameters, and also we're going to discuss about some definitions. What is the population parameter, what is the sample statistic, and so on. So in general, the question is the following. So I would like to know what is the average blood pressure of all of the women over 45 years old in Uzbekistan. From the medicine perspective, it would be interesting to know. The problem is it is infeasible, it is impossible to do this. We can't really just measure the blood pressure for all of the women over 45 years old. And what we can do is we can estimate this number, right? We can approximately say that, hey, this number is going to be like this, or it is going to be within this interval. Or in economy, it would be interesting to know what is the variance or difference in variance of the income of the taxi drivers in two cities. Again, we can't really just calculate this by just measuring all of the incomes from all of the taxi drivers in these two cities, right? So we can estimate those parameters. So in sociology, you would be interested to know what is the proportion of people who believe to the global warming. And industry, you would be interested to know what is the average weight of the 2-kilogram package of potatoes. So here I mean that whenever you've got this 2-kilogram package of potatoes, you should know that it is not exactly 2,000 grams, right? So it might vary a little bit, okay? So you would be interested to know the average weight. So in average, it is going to be about 2,000 grams. But again, so it might be a little bit different. So you would be interested to estimate those parameters. So for example, from the computer science, you would be interested to know what is the average lifetime of the phone batteries. Right? So before producing this, or after producing 1 million of the phones, you can't really just check this. So what you need to do is you need to take samples and you need to estimate the population parameter using the sample statistic. So what is the parameter? So the parameter is the numerical value which represents some properties of the population. Whenever you calculate the mean of the population, it is going to be the parameter. Or the standard deviation of the population, it is also going to be a parameter. And when you calculate the proportion of the population, it is also going to be a parameter. And in contrast, we are going to say the numerical values or numerical properties of samples as statistic. So whenever you calculate the mean from the population, it is going to be the parameter. So for example, the mean blood pressure of all of the women over 45 years old in the whole country, it is going to be the parameter. But if you take a sample of 10 women over 45 years old and you measure the blood pressure and you find the average of this 10, it is going to be statistic again. So you can imagine you've got a population of items, of people, and the mean of this population is going to be the mu, and we call this as a parameter. And when you take a small sample of this population and calculate the mean of the sample, x bar, it is going to be statistic. So our idea is to estimate this mu in order using the x bar. We would like to know what is the mu using the x bar. So we are going to use, in particular, x bar in order to estimate the mu. So for variance, we are going to denote the population's variance as sigma in the square. So this letter here is called sigma. And for the sample, it is simply denoted as S. If you remember, the square root of variance is called the standard deviation, right? So standard deviation of a population, in this case, is going to be simply sigma, and the standard deviation of a sample is going to be simply S. At the same time, we can estimate the proportion of population, P, using the sample's proportion, P hat. So for all of these estimations, we are going to use samples and their statistic. So in particular, today we are going to talk about the estimation of the x bar, estimation the mean of a population. And let's discuss this through the steps, the instructions, and the theory a little bit. And at the end of the lecture, we're going to do a small example. Well, the idea is like this. So let's assume that you went to the bookstore. so open air bookstore, where lots of people are selling their books. The prices are not fixed, the prices are not electronic, so you don't have the database for all of those books because it is open air bookstore. But still, you would like to know what is the average price of the books, right? So it is really difficult to know for you because there are thousands of the books. You can't really just go through all of them and know their prices in order to calculate the average price. But what you can do is you can estimate this. The easy way to estimate the average price of all of the books would be to just take a sample. So just choose some books randomly or during another sampling process, and then calculate the mean of the sample. So, and an X bar is going to be the estimation or the 1 point estimation of the mean. So let's do an example. So I went, let's say, to the local open air bookstore near the central Univermarkt in the city, and I would like to know what is the average price of the books there. So in order to do this, I choose 32 books. The prices of those 32 books in US dollars are listed in the following table. So what I can do is I can calculate the average of those books. So in order to do, I just need to sum all of the numbers. It is going to be 34 plus 34 plus 38 plus and so on. And at the end, I have to divide this as 32. So this is going to be denoted as an X bar. So you can easily do this in a computer or using a calculator. So you can get the answer to be equal to the 74.32. Well, that's the samples average, right? So we call this as a sample statistic or the samples average. What we can say is that, hey, the average price for all of the books in this open air bookstore is equal to the $74,000 or $74, which is going to be like a really rough approximation, right? The problem is we can estimate the population parameter just using 1 point. This is going to be called as a 1 point estimation. And it is not really good estimation because your sample is really not reliable for the outliers, right? So if your sample would include one of the outliers, say one book which is super expensive, and there's only 1 or 2 books, this kind of such expensive books in this local store, your sample's mean is going to be really different. It is going to change the mean really a lot. So 1 point estimation is not reliable. What we can do is we can create an interval around the sample mean. So we are going to create an interval by just adding some error margin to the X bar, and by just subtracting some error margin from the X bar. And we are going to call this interval as a confidence interval. So instead of claiming that the mean average price of all of the books in this big store is going to be exactly $74,000. We are $74, sorry. So we are going to say that it's going to be $74 plus minus some plus minus $5, for example, or plus minus $6. So this is going to be called as a confidence interval. The question is, so how big we should choose this interval? So should it be big or should it be small? So, well, it depends, it appears, on the confidence level, how much confident we would like to be. So there are standard values of the confidence level. So it might be equal to the 90%, which we are going to denote as a 0.9 and a decimal form. And it is going to be equal to, so depending on this confidence level, we can create one interval. At the same time, the confidence level can be equal to the 95%. In a decimal form, it is going to be denoted as 0.95. Well, you can see here that as the level of confidence is increasing, my interval is increasing as well, which is logical, right? So if I would like to be more and more confident about my interval, I just need to choose bigger and bigger interval. If someone asks me, what is the average height of all of the students at this university? And if I would like to be confident more about my estimation, I would just choose a huge interval, for example, between 1.5 meters until 2 meters. Well, the question is it necessary or is it useful to have a huge interval for parameter estimation? Well, probably not. So probably you would not be interested to know that the average height of students in this university is between 1.5 and 2 meters, right? So you want to have this interval smaller and smaller. But you would like to be, at the same time, more confident and confident. So, well, there is always this balance. So as we are going to go through the problems, you're going to see that you need to always keep the balance between the confidence level and between the width of your interval. Well, again, the question is, what does it mean mathematically? This confidence level is equal to the 90% or 95%. Is it what we feel about this interval? So I feel that I'm 90% confident that the mean is going to be in this interval, or 95% confident that I'm going to that the mean is going to be in this interval. But probably this is not what we feel, right? So mathematical explanation is that there is a probability that the mean, actual mean, is going to be from this interval is equal to 0.9. Okay, so it is related with the probability. So the confidence level C is the probability that the population parameter, mu, lies in this interval. So it may lie in this interval, it may not lie, right? So we are estimating this, so probably this mean is going to be from this interval, but there is a probability that it is not going to be from this interval. Right? So you're estimating, for example, the average height of students between 1.5 and 2, or between 1.7 and 1.8, but maybe the average height is different, right? So the probability that the average mean, so the mean of the population is going to be from this interval, is the confidence level. Well, it is going to be mean, so the same story for the population proportion, but we are going to come back to the population proportion in a moment. So where this E is going to be called the error margin, and I would be interested to know how to calculate this. So we already know a couple of things about this error margin, right? So we know that as we would like to be more and more confident about our interval, if the confidence level is going to be increased, then this error margin is also increased. So the error margin is proportional to the confidence level. Well, at the same time, so we're going to see this later on as well, the error margin depends on the sample size. So if you would like to express the population mean using the sample, so it is always better to choose a bigger sample. So, well, if you would like to know what is the average price of the books, so what do you think, what is better, choosing 32 books or 320 books? Well, obviously, if you choose 320 books into your sample, your estimation, your approximation of the population mean is going to be better. Right? So the error margin in this case is going to be inversely proportional to the sample size. So bigger the sample, smaller the error margin. So smaller the error margin means that your interval is going to be smaller and smaller. So well, you need to always keep in mind these two things, that the length of your interval depends on the confidence level and as well to the sample size. But what is the exact formula for the error margin? So before we discuss about what is the exact formula for the error margin, let's discuss the basis of all of the theoretical basis of all of the things which we are going to do today. So what I want is I would like to choose samples from population. So I would like to know what is the average price of all of the books in the open air bookstore. I choose one sample of 32 books, and I calculated the average price of the 32 books, and I've got $74.32. But at the same time, if I choose another sample and if I calculate the mean of another sample, I might get a different number. Well, every time when I choose a sample and calculate the mean of the sample, I'm going to get numbers randomly. Well, this X bar, which is the sample's mean, is a random variable. You take one sample, two samples, three samples, and calculate the means, and those means are going to be random variables. And there is a famous theorem in probability theory, which we have discussed so far, a couple of weeks before, which is called central limit theorem, which claims that no matter what is the distribution of your population, but if you choose samples, then the mean of those samples are random variables, and they have the normal distribution. So, well, the distribution of these X bars have the normal distribution. And it is more or less easy to evaluate the probability that the mean is going to be within some interval, right? So this is the main idea. So this is the basis, theoretical basis, how we are doing this estimation. Central limit theorem. When you choose the samples, the mean of the samples have the normal distribution. And the C confidence level, which is the probability, right, is going to be the area in between of this region, so under the standard normal distribution curve. And we're going to choose this in a way so that these two areas on the tails are going to be the same. So this is the meaning of the C. Well, we are going to see the C, the confidence level for the different curves later on. For example, for the variance, the C is going to be the area under non-symmetric curve. So, but still the definition of the C, this confidence level, is the area under the curve, the density curve, so that the areas in both of the tails are going to be the same. So these two areas are the same. So what is exactly the values of those areas? So since the area on the middle is equal to the C, the rest of the area is going to be equal to the 1 minus C. And since both of the areas on the tails are the same, so one of them is going to be equal to 1 minus C over 2, another one is going to be equal to the 1 minus C over 2. Okay, so this is how we're going to find this. So for example, if the confidence level is equal to the 0.9, then the area on the left-hand side is going to be equal to the 0.05. The area on the right-hand side is going to be 0.05 as well. The most important part of this problem is to calculate so-called critical points. Well, again, in every problem, you will be given the confidence level, 0.9 or 0.95, and just depending on that, you need to calculate the critical points. And in order to know what is a critical point, you need to use so-called Z table. Well, if you remember, the Z table is going to give you the areas until certain points Z. Well, in this case, this area is going to be denoted as the phi of minus ZC, the area until the point minus ZC. At the same time, the area which is measured from the left until this point here is going to be denoted as the phi of ZC, the area until ZC. Okay, so well, this table is going to give us the areas until a certain point. If the confidence level is equal to 0.9, then the area until ZC is going to be equal to the 0.95, right? Because it is the sum of the tail plus the C itself, right? So the tail's area is always going to be equal to the 1 minus C over 2. This area is always C, and if it's sum, it is going to be equal to the 1 plus C over 2. You can get the common denominator and you can calculate this. Well, in this case, 1 plus 0.9 over 2, it's going to be 0.95. So what we have to do is we need to find the Z, the critical point, which corresponds to the area 0.95. Well, in order to do this, we need to go to the table. And inside this table, we need to find the areas, right? All of them are the areas. So we need to find the area closest to the 0.95. So I can see here that this area, 0.9495, is the one which is the closest one. And I'm just going to find a value from the first column and the first row, 0.6 and 0.04, 1.6 and 0.04. I have to sum them in order to find a critical point. Well, in this case, it is going to be equal to 1.64. The right critical point in this case is going to be 1.64. The left one is going to be simply minus 1.64 because this curve is completely symmetric. Okay, so this is how we find a critical point. Again, the basis of all of the things which you are doing is the central limit theorem, and we find a critical point depending on the confidence level, and we are going to plug this into this formula in order to calculate the error margin. Well, the mean of the population is going to be within this interval, x bar plus the e, x bar minus the e, where the e is going to be calculated by just multiplying ZC, the critical point, times to the sigma, the population standard deviation, divided to the square root of the sample size. Well, if you remember, in a couple of slides before, we discussed that the E, error margin, defines the length of your interval as proportional to the confidence level, to the Z, okay? So the bigger the confidence level, bigger the Z, bigger the E. At the same time, it is inversely proportional to the sample size. The bigger the sample size, smaller the error margin. Well, this is how we're going to calculate this. So you need to keep a note that when the sample size is bigger than 30, we are going to substitute the sigma with the s. So because the problem is, so you're estimating the mean of the population, how you would know the sigma? Well, sometimes you know this because of the previous experience or some problems, or there are some methods to estimate this. But usually we are going to simply substitute the sigma, the population standard deviation, with simply the samples standard deviation. Well, let's do the problem. So I'm going to choose, I would like to still estimate the average price of all of the books in the open bookstore. In order to do that, I chose the sample of 32 books. I can calculate the mean by just adding all of the values, 34 plus 34 plus 38 plus and so on, plus 120 divided to the 32. That's going to be x bar. Well, at the same time, I can calculate the standard deviation. So in this case, I'm going to subtract from each point. I'm going to denote this as a xi, the mean of the sample. I'm going to square this, and then I'm going to find the difference in the square for all of the points, and divide this as n minus 1 in this case, which is 31. And this value taken from the square root is going to be the standard deviation. For the mean and the standard deviation of this sample is going to be calculated like this. So let's assume that I made this calculation. So you can do this at home using a calculator or computer, or there are online calculators who allows you to calculate the standard deviation of the sample. And you can calculate that the mean is going to be equal to the $74.32, and the standard deviation is going to be $23.44. Well, if you remember so let's do the problem. So I would like to estimate the population mean. So I need to know the x bar in S. But if you remember, the formula for the error margin contains the critical point as well. So critical point times the S divided to the square root of 32, right? So our sample is more than 30, so that is why I'm going to substitute the sigma with the S. So in order to find a critical point, we need to know what is the confidence level. And if the confidence level is 90%, we have already calculated this, that the critical point is going to be equal to the 1.64. Right? So the critical point is going to be equal to the 1.64 for the 90% confidence level. Sigma is going to be equal to the 23.44. We've just substituted this with the sample's standard deviation divided to the square root of the n, the sample size. And this is going to be equal to the 6.79. Well, this is the error margin. This is not the interval yet. What we have to do is we need to add this error margin to the x bar and subtract this number from the x bar in order to find the interval. It is going to be 74.32 plus minus 6.79. So this is going to be our estimation. So let's do this together. So the mean, the average price of all of the books in this big store is going to be in the interval within x bar plus the e and x bar minus the e. In this case, it is going to be equal to 74.32 minus 6.79 and 70.32 plus 6.79. Well, today we've discussed about how to estimate the population parameter using the sample statistics. In particular, we discussed how we can estimate the population mean using the sample's mean. And we've learned about what is the error margin, what is the confidence interval, and I hope that this lecture was useful for you.